Sorry. Okay, I have started recording. Okay, so these are the the accounting or the login activities. We also have the operating system performing protection and security functions. Okay, we've talked about what protection is. We've talked about what security is. Okay, protection involves ensuring that all access to the system resource is controlled. And security also requires that users from outside the computer system are authenticated. Okay, this security also extends to the defense of the external input-output devices from invalid access attempts. So if anybody wants to access your computer from a network, if someone puts a pen drive and the pen drive tries to write data onto your hard disk, all these are secured by the operating system to provide efficient operation. Okay, excuse me. Now let's look at a view of the computer system, the operating system. Okay, if you recall the functions that we've talked about, okay, these are the functions that are put together in the form of services that are provided by the operating system. So remember the program execution, the I/O operations, the file system manipulation, the communication, and the error detection. These are there to provide the user with these features. And then we have the resource allocation, the accounting, and protection and security for the efficient running of the operating system. So these are the services provided by the operating system. We have the system calls. The system calls. So these system programs or the computer programs that we use, they make system calls to these services. If a program needs to execute a program, it needs to make a system call. If a program needs to execute an I/O operation, it makes system call. It needs to access the file system. It is done through system calls. So all these services are executed or accessed with the help of system calls. Then we have the various user interfaces, the GUI, the batch, and the command line. Okay, so this is the overview of the operating system services. All right, let's look at the operating system interface. Let's start with the command line. What is the command line? What is the command line? Some operating systems include the command interpreter. Usually this is in the kernel. Okay, if you look at the Windows operating system and maybe the Unix operating system, they treat this command interpreter as a special program. Okay, now if you are on the Windows operating system, I'm sure you have seen the CMD, that is the command prompt, right? Okay, the CLI or the command line interpreter allows direct communication or direct command entry. You don't have to go through any nook and cranny. Just give your command directly and the operating system will take up this command and execute on the user's behalf. Okay, now there are different flavors of this command line implementation. On some computers, they are called shells. On some computers, they are called the CMD. Now, we are going to talk about these shells. They primarily fetch a command from the user and executes it. So this is why we are saying that if you don't know what you are doing, you don't want to play with the command line interpreter, because it will execute your instruction without any excuse. These commands can be implemented in two general ways. One, the command interpreter itself has some code that it can use to execute some of the commands. Okay. Number two, this can be done using system programs. If the interpretation of the command you want to execute is not in the command interpreter itself, then it has the power to execute some of the system programs. For example, if you want to do ipconfig, if you execute ipconfig instruction in your command line, this ipconfig is a system program, and the command line has the ability or the power to execute this system program. Okay, but if you execute a command like echo hello, this echo command is stored in the interpreter itself, and therefore it will not go anywhere. It will remain in the interpreter and execute your echo command. Are you with me on that? Are you with me on that?
Yes, sir.
All right.
Yes.
Okay, so I'm sure you, from your previous courses, you know of the shells there are. Okay, we have the bone shell, we have the C shell.
No, sir. No, sir.
You don't know?
Yes, sir. I don't know.
Sir,
We don't know.
you don't know. Okay, so these are examples of the shells that we have. We have the bone, BOURNE. We have the bone shell. We also have the C shell. These are different flavors of the shell.
PowerShell.
Yes, PowerShells. The PowerShell is just a name, but these are the flavors. We also have the born again shell. Born, BOURNE. The born again shell, what we call the bash. This bash is what you usually see on Linux systems. Okay, the born again shell or the bash. We also have the corn shell, KORN, the corn shell. These are examples of some of the shells that we have. And all these are command line interpreters. Okay, when you enter your command, it either executes the command by itself, or if the interpretation is not in the command, if it has to execute any program, it will go and execute the program. Okay. We have the graphical user interface. All right. So rather than entering a command in the command line interpreter, like we all know, the GUI employs the mouse-based window and menu system characterized by a desktop metaphor. Okay. The first GUI appeared in the 70s at a facility called the Xerox PARC. They introduced the first GUI. Okay. The computer that used the first GUI was called Xerox Alto. Okay. GUI became more widespread with the advent of Apple Macintosh. So you see, the GUI is not by Microsoft, like people usually say. Apple first, it started with Xerox, and then Apple came in the 80s. And then Microsoft's first version of Windows, version 1, was based on the addition of GUI interface to what they were using previously, that is the MS-DOS. Okay. Unix and Linux have command line interpreters with optional GUI interfaces, like the CD, like the KDE, like the norm. All these are in the Unix flavors. Okay, so let's move away from that to system calls. That is very important. System calls provide an interface to the operating system. If you look at the diagram, we have a source file and destination file. These system calls are typically written in high-level languages, such as C and C++. Okay, look at this program here, a simple program to copy a file from one location to other. Look at this. The name is called the call sequence. First, what do? The program will acquire the input file name, right? What is the input file name? That is the name of the two files that you want to copy from where and to where. These names can be specified in different ways. Maybe you want to type or you want to just paste. Okay. If you have a command line system, this approach will require a sequence of system calls. First, you acquire the file name, you write the prompt to the screen that you want to get the file name that you want to copy. Then you accept the input by copying. Then you acquire the output file name by writing the prompt on the screen. Maybe you type the name that you want to paste your file into, then you accept. Now you open the input file. Here I'm talking about the command line. Oh, let me write the command line. If you want to copy a file, what command do you give in Windows in the command line? What do? You do CP, right? First dot. Let's say we are copying a notepad. So first.txt to second.txt. I hope you can see what I have just typed. So this is a command to copy a file, the content of a file called first.txt, and paste it into a file called second.txt. So this will be executed using this call sequence. All right. Are you with me?
Yes, sir.
Yes,
Good.
sir.
I hope you can follow. So if you look at this command, all these system calls will be executed just to complete this simple instruction. Okay. So frequently, system calls execute thousands of system calls per second. So your computer system within a second can execute 1,000 system calls. So imagine you just right-clicking and copying and pasting a file. If all these are going to be executed, then you can imagine the speed of the computer systems that we use. Most programmers never see this level of detail. All you do is you copy and you paste, or you just give your command and it is copied. Application developers design programs according to an application program interface. I'm sure you have all heard of API. The API specifies a set of functions that are available to an application programmer. Okay, these functions, okay, allows the programmer to make use of the system calls in the system. So what you just do is you do cp first.txt to second.txt. Whatever happens in the system is none of your business. Okay, the API that your command executes on is not part of your concern. There are three most common APIs that are available to application programmers. The first one is Windows 32 API for Windows system. Then we have the POSIX API for computers that are POSIX based, which include virtually all versions of Unix, Linux, and Mac operating systems. Then we also have the Java API that are for applications that are designed to run on the Java virtual machine. So it is the API that invokes the actual system calls on behalf of the application programmer. So if you're writing an application, all you give is your CP command, CP first.txt space second.txt. Okay, this command or this instruction will be executed on the API, and it is the API that will execute all these system calls on behalf of your application. Are you with me?
Yes, sir.
So I'm sure if you have done Visual Basic, you know of some of these API, right?
So we are now doing it.
You've not done Visual Basic.
We are doing it this semester.
Oh, okay, good. All right. So I'm sure you will come across some of these APIs. All right, good. Okay, so I'm just going to go through this. It is a text that I want you to know. So this is an example of a standard API. Okay, if you consider the instruction read that you find in Unix, this is Unix environment or Unix systems, and this is also the same read on Windows application. This is the Win32 API. Okay, if you look at them, they are all doing the same task. Read is to read a file, and read file is to read a file, the same thing. But if you look at the various system calls, okay, or if you look at the parameters, okay, that your read has, it has the FD, it has the buffer, it has the size, the count, okay. The FD is an integer, the buffer is void, the count is a structure of size. So if you look at these parameters and you compare it to the Windows environment, the Win32 API, this is a Boolean function. In the Linux environment, the return value is what? It's a structure on its own. Okay. In the Windows environment, this is a Boolean, the read file. So it will return true or false. In the Linux environment, it will return the size of the file. And these are the parameters: the file, the buffer, the bytes to read, and the bytes that have been read, and the overlap. The file is a handle, the buffer is a void, the bytes to read is in words, the bytes that have been read is in LPD word. So these are the parameters. If you look at these two APIs doing the same task, they all have different system calls that are executed on the operating system. So as a programmer or as a developer, you need not to worry about all these internal operations. You just make a system call to the read file, and then you provide the various parameters. Whatever happens in the system is none of your business. Okay, here's an example. Why would an application programmer prefer programming according to an API rather than invoking the system calls by themselves? Number one, these are the reasons. For program portability, okay, with the help of the API, a programmer can expect that his or her program will compile and run on any system that supports the same API. So remember, in the objectives, we were talking about why some of the applications will not run on other operating systems. If I run or if I create a program that uses this API, this is the Windows API, Win32, okay, the parameters that I will provide to my read file, how many? 1, 2, 3, 4, 5. These are different from the parameters that will be provided on a Linux environment. How many? 1, 2, 3. Therefore, a program that is designed for the Linux environment will not run on Windows environment. So if you see a program that was designed for Windows, you take it to Linux, ordinarily it will not run because the APIs on both operating systems are different. Number two, actual system calls can often be more detailed and difficult to work with than the API. So if you want to actually do the system calls yourself as a programmer, it will be more difficult. And the detailing is so much overwhelming or for just an ordinary programmer. Compilers have a set of functions that are built into their libraries called the runtime support system. This runtime support system will provide a system call interface that will serve as a link to the system calls. So what the compiler has is that it has some runtime environment. This runtime environment understands and can make appropriate calls to the operating system using its system call interface. So if you compile a program and your program requires Win32, your compiler has that system call interface that will be used to call the Win32. If you need the POX6, the compiler will be able to call the POX6. That is why you can have one compiler running on both Windows and Linux. Like you have the Borland C++ compiler. This compiler can run both on the Windows environment and in the Linux environment. That is because it has an inbuilt library functions that understands which of the system calls to execute. So the system call interface intercepts the function calls in the API and invokes the necessary system call within the operating system. All right, good. So this is the diagram to illustrate that. Here you have your user application. Your user application cannot understand all the necessary system calls in order to complete a function. Therefore, with the help of your system call interface, okay, your application can execute the various system calls. So once again, remember, in the user application, once you execute this system call, your operating system switches from the user mode to the kernel mode to actually invoke these system call functions because these are privileged instructions. Okay. Now let's look at type of system calls that there are. There are 6 different system calls that one can make use of. We have the process control system call, We have the file manipulation, device manipulation, information maintenance, communications, and the protection system call. Okay, let's take a look at them. First is the process control. When we say process control, I think it is straightforward. Okay, it is used to create process, terminate process, end process, abort process, load process, execute process, get the attribute of a process, set the attribute of a process, wait for time, wait event, signal event, allocate memory, and free memory. All these are examples of process control system calls. Okay, we have one that can dump memory if there is an error. Suppose an application execute out of the ordinary, then there is an error. That means the memory that was allocated to that process has to be recouped, or it has to be dumped. So that is also in the system called the process control system call. Okay, all right. We'll talk about logs and debugging. For file management, we have system calls that can create a file, that can delete file, that can open a file and close a file, that can read, write, and reposition the cursor in a file. If you have this file, for example, and it is being read, you can use a system call to, suppose you are at this stage in the position of the file, you can use a system call to reposition and bring the cursor to this position here. Okay, then we have a system call that can be used to get and set the file attributes. These are for file management. Then we have for device management. We have system calls that can request a device, that can release a device if it has been finished. I mean, it has finished its usage, that can read, write, and reposition the device, just like the file. You also have a system call that can get device attribute, set device attribute, or logically attach or detach a device. Like when you insert a pen drive, you hear a sound indicating that the pen drive has been recognized. At that time, it has been attached. And then when you also remove the pen drive, you hear a sound telling you that the pen drive has been removed successfully. At that time, it has been detached. All these are done with the help of system calls. Information maintenance. We can use system calls to get the time or the date. We can use it to set the time or the date, get system data, set system data, get and set processes, file, or device attribute. In communication, we use system calls to create, delete communication channels, send, receive messages. Okay, we'll talk about the message passing model. Okay, how message is passed. When we get there, you explain this. So you can use, excuse me, you can use system calls to send or receive messages if the message passing model, I'm using the message passing model, whether it's host to host or process to process or whatever it is. You can also use the system call to send or receive messages from client to server and vice versa, from server to client. You can use system calls to actually create and gain access to memory regions. If the memory is shared, then you can use the system call to gain access to these memory regions. Transfer status information, attach and detach remote devices. All right. For protection, we can use system calls to control access to resources, to get and set permissions on resources, to allow and deny user access. All these can be done through system calls. So if you take a Windows and Unix operating system, these are some of the examples of system calls, okay, for Windows and their related system calls in Unix. So to create process in Unix is fork. To exit process in Unix is exit. To wait for a a single object in Unix is wait. These are all for process control. Then the remaining are for file, the device, the information, the communication, and protection. So you can study this at your leisure hours. Okay. So why do, please, do you have any questions? Are you with me?
Yes, sir.
Yeah. Yes,
So
sir.
why are applications operating system specific? Why is it that some applications will run on Windows but will not run on Linux? Some applications will run on Windows XP, Windows 7, but not on Windows 10. Okay. Applications that are compiled on one system usually not executable on other operating systems. This is because each operating system provides its own unique system calls. All right. Each operating system provides its own unique system calls. So imagine you have a program that uses the create process system call, like let's say the tempo run. Assuming this is your Linux, your Android operating system. For your tempo run to execute, it needs to perform this system call create process. So in writing your tempo run, your first line of code is create process. Then you take this tempo run to a Unix operating system. Unix operating system does not understand create process system call. Okay, so your first line of statement in the tempo run is not understood on the Unix operating system. Therefore, that program, the tempo run, cannot be executed on the Unix environment. Okay, so each of these operating systems, they have their own file systems, their own file formats, the way the memory is arranged, they are different. Apps can be multi-operating system if the application is written in an interpreted language like Python, like Ruby. Okay, these application programs are not normal programming languages, they are interpreted. That means they are just executed as they are. So when they get into the operating system, they will make the appropriate system calls in order to execute the instructions. They are not programming languages. Python is a technology. Ruby is a technology. It's like PHP is also a technology. So when they get into the computer system, they will execute the appropriate system calls. All right. So when you write a program in these languages, then they can be executed on multiple operating systems. Apps that are written in language that includes a virtual machine. Okay, you know the Java virtual machine is also available on all the operating systems. You can find the JVM on Windows. You can find it in in Unix operating system. You can find it on the Android. You can find it on the Mac OS. You can find it on the iOS. Because this JVM is available on all these computer operating systems, when you write an application in Java, It can execute in all these operating systems. Okay. And then apps that use standard language, like the C. The C also uses standard language. It has a compiler that every time you run will compile your application. And because that compilation is done on the current operating system, it adds the linkers and the loaders that are needed in order to execute your C program. So if I write one C program and I compile it in Windows 10, for example, Windows 10 will add all the necessary files in order to run my C program. If I compile it on Android, Android will add all the necessary applications in order to run my application. Okay, so we have applications that can be operated on multiple operating systems and ones that are unique to one particular operating system. We have the application binary interface, the ABI. This is architecture equivalent of the API. It defines how different components of binary code can interface for a given operating system, given an architecture. Which this is one of the topics we will look at getting to the latter part of this course. Class rep, has there been an adjustment to the existing academic calendar?
No, sir.
So are we following the same calendar?
Sir, please, since they've not bring any new one out, I think we are following that one.
That means by that calendar, we are supposed to be in our mid semester, right?
Yes.
Yes, sir.
Okay.
It's not possible. I think maybe a new one will come.
Okay, so I'll talk to my HOD and ask if the calendar has been adjusted. I'm sure it should be adjusted. All right.
I said, please, Kumasi campus, who is the HOD, please?
Oh, currently we don't have HOD. The man I spoke with, Mr. Nuku, he was the former HOD, but you see now,
Yes,
when they restructured the campuses, we all fall under the HOD in Accra main campus.
okay.
Yes. So now we don't have HODs at the satellite campuses. All right. Okay. Are there any questions, please? Okay. All right. If there are no questions, I'd like to end the class here. Please remember to get the notes from the website. I will put, okay, so there is assignment, 3 assignments. I will also put them on the website so that you can submit them. Remember, the submission will be open from tomorrow till next week when we have class like this. If you don't submit, you are in trouble.
Yes, sir.
All right, good. If there are no questions, I am ending the class here. Thank you all for coming.
Sir, please.
Yes, Osei.
Sir, please, at first, they were giving us some bundle for the online class, but now I think there's nothing like that.
Okay.
Is there any way for it, please?
Mr. Osei, as for this one, I think you may have to make the appeal through your SRC executives or to the students, the Dean for Student Affairs.
Okay.
Okay, sir.
Yeah, I think
Sir.
he can push it forward. Yes.
So I learned when they were giving us, they were giving the teachers also. So are you guys still receiving yours or you buy your own data?
Hey, if you want to know anything about teachers, become a teacher.
Hello, sir.
Yes, sir.
Yeah, I want to ask a question.
Yes, Bafo.
Yes, sir. So with regards to you were talking about pen drives.
Yes.
Yeah, where when you insert the pen drive issues and stuff, like currently my machine, if I insert the pen drive, it doesn't show, and I can't even locate the pen drive. But if I insert into another laptop, it shows and you can read it. So
Your driver's access time.
Oh, good.
Come again.
So look out for the drivers, and also is it just pen drives or any USB device?
Is it?
Is it just
It's
pen
only
drive
it's only
or you
pen drive. Yes,
come again?
it's only pen drive.
It's only pen drive.
Yes, sir. It's only yes, sir.
How many pen drive like USB slots do you have on your computer?
I have about 4.
And all of them are not working.
It works like I don't know how to explain, but you see the same drive. For instance, if I insert into another machine,
Okay.
yes, if I insert into my machine, it doesn't show and it can't even read.
So have you tried other pen drives with your machine?
Yes, I've tried about 4.
And all of them are not reading. On all
Yes,
the
sir.
4 USB drives on your computer.
Yes, sir. Yes, sir.
Okay. So I think the best thing is to update the drivers. Update the drivers. That would be the first thing. Since all pen drives are not working, if other USB devices were not working, then I would ask you to open your system and check the connect. Maybe the USB control unit cable has come off or something. But since you say other other USB devices are working, it's quite strange. Maybe you should just do an update of your computer system and see. Update the operating system and let's see.
It used to work. I installed the new Windows about a week or so ago, and after I installed Windows, it started doing that.
And then it's a driver issue.
Uh,
So go to your device. Go to your device. Oh, please, guys, can you mute your mics for us? Nigel, please mute your mic for us. Thank you. So what you do is, you see, every computer has their specific drivers. So go to the website for your system. Maybe let's say if it's HP, go to their website and look for the driver for the specific operating system. For example, I have a Lenovo computer. If I install any operating system apart from Windows 10, most of my devices will not work. So I have to go to their website and download the specific drivers for that operating system, right? So even my mouse pad will not work if I install any other operating system. So I have to go to the Lenovo website and download the driver for my mouse pad for that particular operating. Let's say if I install Windows 7, I must go and download the driver for Windows 7 before my mouse pad will work. You understand? So since you have done a new installation of the operating system, go to your computer's website and see if you can get specific drivers for the USB, right?
yes, sir. Yes, sir.
Yes. Okay.
Thank you, sir.
Sure, you're welcome. Please, any other questions? Okay, Nigel.
No question.
Nigel, you have a question?
No question.
Okay, Simon, did you have a question? Okay, good. If there are no questions, we are ending the class here. Thank you guys for coming. I'll see you next week.
Thank you,
Hello.
sir. Bye-bye.
Salom, your hand is up. Do you have a
Bye-bye.
question?
Yes, please.
Okay, Salom, please go ahead.
Sir, please, I want to know, since we are taking this course online, do we have any
Come again.
practical session?
If I'm getting
This
you
network is
well,
bad.
you're asking if we are going to have a face-to-face session. Yes. That is something I am working on. I am hopeful that at least we will have some
Sir, please,
face-to-face.
I said, do we have any
Practical. Yes. There will be practicals.
I mean, if there are some practical, yes.
Yes, there will be. There will be. There will be. And when we get to that bridge, we will cross it. All right. Okay, guys. Thank you all for coming. I'm ending
Say
there
bye bye.
now. Okay, bye.
Bye bye.